Excuse me, sir.
Yes.
Is this tube 8 or tube 9?
I think it's tube 9 should be.
We haven't done tube 8 yet, sir.
What is tube 8?
Yeah.
What is the I think we have done it probably last week.
Because last week we did tube 7.
Let me see. I think we have done the trend analysis. Last week we did the trend analysis, which is week 8, because there was some break somewhere. That's why we have. Last week we do the trend analysis, MK test, and Spearman row test, I can recall. Okay, so let me screen share with you. Okay, so it is on here. Okay, so today we have our tutorial 9 on principal component analysis and cluster analysis. So in this problem, can you see my Excel data here?
Yes.
Yes, sir.
Yes, sir.
So we see that there are station on my first column. So station ID is there. So I have data for 56 stations or catchments, all from drainage division 2. And we have latitude and longitude of the stations at the gauging location where we measure the stream flow data. Then we have rainfall intensity with 1 hour duration and 2-year return period. So I means intensity of the rainfall, and 12-hour duration and 2-year return period, 1 hour duration, 50-year return period. And then we have 12-hour duration and 50-year return period. And next we have rainfall intensity for TC duration. TC is the time of concentration, which is the function of catchment area. So TC and 2-year return period. So TC 5-year return period. TC 10-year return period, TC 20-year, TC 50-year, TC 100-year return period. So these are all measures of rainfall intensities under different ARI and different return period and durations. And then we have mean annual rainfall in millimeter, evaporation in millimeter, stream density in kilometer per kilometer square. And we have slope S1085. That means that slope of the central 75% of the stream. So that is the difference in the river bed at 85% and 10% length from the gauging location divided by the distance between that part of the river. This unit is meter per kilometer. And forest is the fraction forest. So 0.60 means 60% of the catchment is highly forested, with the medium and dense forest. So do you have any question on the data or any of the catchment characteristics? Ali Ahmad, do you have any question?
No, sir, at this moment, I think it is okay for me.
Do you understand all the catchment characteristics here?
Yeah, sir, rainfall intensity for time, concentration for different return periods, like 2, 5, 10, or 20, 50 years. like 100 years, and mean annual rainfall and evaporation and stream density and the
So
slope.
can you tell, can anybody tell me that why we are using so many different rainfall intensities? And then again, we have MAR, mean annual rainfall. So why we are using so many characteristics of the rainfall?
Sorry, is that ITC 2510? That's for the AEP, right? Not AR. Like, okay, yeah. These are all the 6 AEPs. So I guess we're using it for each individual AEPs.
So this is the return period or same thing. 1
yeah.
in 2, you can say, yeah.
Yeah. So like maybe we're using it for like all of the return periods, because for every return period, the models we make have different variables. So every model for every individual return period is different. So I guess we have to use all the time of concentration.
So you're right, because for different return period, there might be different rainfall intensity that is more important. For example, if you want to estimate a 100-year flow, then 2-year return period rainfall may not be that relevant. Rather, 100-year return period rainfall would be more relevant. Is that right?
Yes, sir.
So that's why it is better to use many different rainfall intensities. Then why we need to use mean annual rainfall again? MAR, why you need to use mean annual rainfall?
So because the mean annual rainfall affects all rainfall into it's dependent on all sorts of rainfall intensities. So if you're using ITC 2510, whatever, like mean annual rainfall is always influenced by that, all the other variables, I guess.
So mean annual rainfall is like a surrogate for many other catchment characteristics. For example, if the mean annual rainfall is higher, that indicates a wetter catchments. So you can see that when the mean annual rainfall is smaller, you can see forest is small generally. So as the rainfall increases, generally the forest percentage increases as well. That's obvious, because if there's more rainfall, then the forest will be more generally. So mean annual rainfall is a surrogate or indirect characteristics of many other variables. So mean annual rainfall is generally important in this kind of flood analysis, rainfall runoff modeling. Why we need to use evaporation?
So evaporation affects the rainfall runoff relationship, because if there's more evaporation, there's less water that can contribute to the runoff, maybe.
That is one way. During the rainfall, then there is some evaporation loss. That's one thing. Another thing is that higher the evaporation, the drier the catchment. And the drier the catchment, more rainfall will be lost into the infiltration, into the soil, rather than appearing into the river or stream. So higher evaporation means a higher loss of the rainfall. So it will inversely affect the runoff generation. So stream density, who can tell me what is the role of the stream density in the rainfall runoff process? Ali Ahmad, can you tell me what is the unit of stream density? How you measure the stream density?
It's meter per kilometer square.
So how we measure it, stream density?
So it is the ratio of the length of the main stream and divided by the area of the stream or whole channel.
The area like you are close, but stream density is the length of all the streams on a topographic map.
Yeah.
Generally 1 to 100,000 scale topographic map, all the blue lines appearing on that map, you measure the length of that divided by the area of the catchment.
Yeah.
So higher the stream density, quicker the runoff will flow down. So you mean that it will create a flash flooding effect. So slope is the same thing. Higher the slope, the quicker the runoff is. What is the impact of forest on the runoff?
So you should lower the rate of runoff because the trees and stuff, they block the water from flowing.
So two things. One is that it will offer a greater resistance to flow. If you have studied fluid like the hydraulics, Manning's equation. So Manning's equations, can anybody tell me what is Manning's equation? Anybody can recall Manning's equation from his memory? I can recall it's V equals 1 by N R to the power 2 by 3 S to the power half. So that means that your N is the roughness coefficient. So higher the N, smaller the velocity of flow. And when you have a bigger forest, bigger thing, then there will be more resistance to flow. So that will reduce the runoff velocity. And also it will increase the infiltration because it will, if the water stops like it retards or slow, then there will be more infiltration loss and evaporation loss as well. So these are the kind of impacts that really affects the runoff. And really you need to understand the impact of each of these variables on the rainfall runoff process if you want to understand what's happening in hydrological terms and to interpret the results of this kind of analysis. Any question on these variables?
I'm sorry, like where do we get, can we get these like the slope and stream density and forest data from any website, or it's not available?
Unfortunately, that is an important question. While we get the data,
to your area today, just regarding the Showdodge Park property you mentioned. Can you call me on 0402 14303? It's Jennifer. Thank you. Bye.
So can you stop when you're talking? If you can mute yourself, that would be good. So we can get the design rainfall intensities from Australian Rainfall Runoff, Bureau of Meteorology website. Is that right? We all know how to get the rainfall intensity. I think I showed you one day. Is that right?
Yeah, you did.
I think I showed on there. And then mean annual rainfall you also can get from Bureau of Meteorology. Evaporation you can get from Bureau of Meteorology. Stream density. And these three, you cannot get it from any source directly, but you have to use topographic map. And then you have to measure it. I'd like to show you one day a topographic map and how to measure all these characteristics. But the problem is we don't have a face-to-face tutorial class or lecture. So maybe I don't have a topographic map in my home as well. It is in my office. Otherwise, I could have shown you how to do it because it's important, particularly those who are, I think it's important for everybody, how you delineate the catchment boundary and then how you measure all these characteristics on a map. That is the practical experience, which is very, very important. Even when I started my PhD, I did not know how to delineate the catchment area, how to measure all these characteristics, because I never saw a topographic map before my starting of my PhD. Although I started my PhD after around 10 years of working, and during that time, I did not have the opportunity to look at a topographic map and open this kind of thing because I was working as a structural engineer, making concrete and all this kind of stuff. So I did not have the opportunity to look at this kind of maps. Anyway, so I had to learn quite a lot in my PhD. Okay, so these are the characteristics because you need to understand the data before you do the analysis. So I try to help you in that. Okay, now let us do principal component analysis. What we'll do, I am copying this data and I will go to SPSS. So I am copying this data and I have opened the SPSS window before. And so can you see the SPSS window?
Yes, sir.
Okay, so this is my SPSS window, and you see I just copy and paste the data here. Control C copy, or paste here by Control V, or you can paste and copy by using your mouse. So this is, you see my station ID and then all the variables coming here. So this is my SPSS window. So once you are in SPSS, you can do a lot of things. So today we'll be doing two things mainly. One is the principal component analysis first, and then cluster analysis. So let us do principal component analysis first. So what are the objective of principal component analysis? Who can recall from the lecture? Why you want to do principal component analysis? Because we want to see which of these variables are more important. And we have a lot of variables here. Around 16 or 16 variables, or I think it's around 15 predictor variables. We want to see which are important, and we want to reduce the dimensions of the problem from 16 dimensions to, say, only few dimensions, particularly into 2 dimensions, PC1 and PC2 dimension. And then we want to see in the plane of the PC1 and PC2 that which of these casements, they come together and they form groups together, or they are homogeneous in some way. So that is the objective of my principal component analysis. So it's very easy to do. So we'll go to analyze, and then we go to data reduction somewhere there, dimension reduction. So can you note it down, dimension reduction? And then we go to factor, and we select our predictor variables. So latitude, longitude, they are not predictor variables, they are location characteristics. So I will not use that as predictors. So I select all of these variables here. And then I want to do a descriptive statistics. I want to do the correlation matrix with the significance level. And then I want to do extraction, which is principal components I want to extract. And I also want to get the script plot. And then I say continue. I can save the principal components in this sheet. So I want to save as variable principal components. And we can ask display factor score coefficient as well. Continue, and if I say okay now, it will be done. So you see here, this is the correlation matrix between the variables. And in the bottom one is the significance level. So the correlation between I12.2 and I12, what is the value of the correlation between I12.2 and I12?
0.949.
0.949.
0.949. And what is the significance level of this correlation?
0.00.
0.000, and then there are some other digits after that, but they have considered up to 3rd digit. So is it significant correlation?
Yes, it is significant.
Because the p value is less than 0.10. So it means it's significant correlation. So you see that a lot of correlations are significant, but there are some non-significant as well. For example, this one here, 0.49. For the last one is 0.214, which is the relationship between forest and another variable. So what is that variable?
So I think it's stream density.
Stream slope, I think it's 1085. So they are not significantly correlated. Okay, so that's the correlation coefficients. And then we can say the first component here is explaining 66% of the variance of the data, which is quite a lot. And second component is explaining 11%. And third component explaining around 9% and so on. And you can see some of the components at the end, they are explaining very little in the data. Then we can say that we have reduced the dimension of the problem from 15 dimensions to almost in third dimension, 3 dimension, or you can say 4 dimension. It's 92% of the variance of the data we are exploring by that way. But 1 and 2, they are explaining around 77% of the variance of the data, which is quite a lot. So this is the script. Yeah. Okay.
Sorry. Can you make one quick question, sir?
Sure, please.
So, like in this total variance explained, we see that only there are 7 variables. They have explained around 99% variance. So, could we just consider only these 7 variables instead of the other one, like those who explained less than 1?
Of course, if you want to do regression analysis, then I will say that you use only up to 7 from the beginning. You don't use more than that.
Yeah. So okay. I mean, those who are the less than 1, we can exclude them.
Exclude them. That's right in the regression analysis. So it's called principal component regression. And also, if we want to see the structure of the data, grouping of the data, then we can use only principal component 1 and 2, just to see, because we can produce a 2-dimensional plot, PC1 versus PC2, and we can see the structure or the grouping in the data, because they are explaining 77% of the variation, which is not bad. Okay, so this is the script plot. We can see that really, like you can see after 7th, it's really very little there. Okay, so now we can go back to the data and we can see our principal component values there. So we can go to our window and then data set. And we'll see that in the data file, it has created some principal components there. So PC1, so it has created 1, 2, and 3. So I have saved only 3. You can save all of them if you like. So basically now we can copy this data and make a plot in Excel to see the group in the data, for example. So I can copy this data. So I am Control C, which is I'm copying the data. And then I can open an Excel sheet and I can really copy this data here. I think it has not copied. So I think I have to go back there again. So Control C. Control B. I don't know why it's not copying from there. It should. So let us see whether it copies now. Yeah, so it's copying now. So this is our PC1. This is our PC2. This is our PC3. So can you see my Excel plot here now, Excel file?
Yes, sir.
With PC1, PC2, and PC3. The first thing that, what would be the correlation between PC1 and PC2? Correlation between PC1 and PC2, what would be the correlation? Will it be very high or low? Ali Ahmed?
I think it will be more than 50%. I guess.
It will be very close to 0 because they are uncorrelated. Principal components should be uncorrelated.
Oh.
Yes, control. So just there. So what is the correlation here? It's 4.97 to the 10 to the power minus 7. It's very small. Is that right? It's close to 0. Okay. So the correlation between his principal components is 0 or very close to 0. Okay. So now what we can do is we can really produce a plot of PC1 and PC2, and we can divide our 56 catchments into a number of groups, for example. So let us do that. Insert, come to the scatter plot, and we can see this is our PC1 and PC2 plot. So in this plot, we can divide the data into 4 groups. So we can say group 1. So for group 1, that PC1 is greater than, is greater than 0. PC1 is greater than 0, and PC2 is greater than 0. So who is zone it is that? That is group 1 here, is that right? So my group 1 is in this quadrant here, PC1 greater than 0 and PC2 greater than 0.
Yes.
So that is my this catchments here. And then similarly, you can do your group 2. Group 2, you can do, I can take this one because I can come clockwise. And so in this case, my PC1 is greater than 0, is that right? Greater than 0. And what is about PC2?
Less than 0?
That's right. So PC2 is less than 0.
So it is bottom right.
That's right. So in group 3, we are going clockwise.
Yes.
So PC3, group 3 will be PC1
less than 0.
Less than 0, and
PC2 is also less than 0.
PC2 is also
less than 0.
Less than 0. And finally, group 4, PC1
less than 0.
PC1 is less than 0.
Less than 0.
Less than 0. And PC2
is greater than 0.
PC2 greater than 0. So this can
correct.
be a 4 criteria of grouping, and we can estimate the PC1 and PC2 as a function of the catchment characteristics. And then we can we can have 4 regression equations for each of the group. And for any unguessed catchment, we can find that where it belongs. So this is one of the usefulness of the principal component analysis.
Is it possible to identify the station ID?
Of course, in the plot, you can do it. So you can see every plot, if you go there, you can see the value there.
Yeah.
So in Excel, you need to know how to identify it. So search Excel that how to label the number by many different ways. So you can say add data levels, for example. Here is data level is added, which is PC2. So from there, you can identify. And there should be a data level that we can select a variable. Add data labels. Is there any? Add data labels. There should be a way to do it. Like you can create a variable with 1, 2, 3 or catchment ID. 1, 2, 3 is better because catchment ID is a long name and it could be difficult. Okay, so any question on principal component analysis? Okay, if not, then we go to cluster analysis now. Okay, so this is our data set now. We want to do cluster analysis. So we go to analyze, and then we'll go to the classify. Analyze and then classify. And then we'll do first hierarchical clustering. And what are the variables we want to use? We want to use these variables. Up to here, up to forest, yeah. So these are the variables we selected. We can label cases by station number. String variable only, so this is a numerical variable. So we have to say catchment 1 or 2, something like that. We have to create a string variable if you want to label it with that. Which I have not done there. So if somebody wants to do it, particularly Ali Ahmad, if you want to do it, you can create a variable with like site 1, site 2, something like that, or C1, C2, C3, something like that. And then you can use that as the your variable name, variable level. Yes. I think that is important.
Yes.
Let us do it. Let us do it because we can create a variable here. This is our catchment 1, is that right? So I'll use C1, C2, C3.
So I think still it will give us the error message for string values, like C is here as a string.
No, we'll change the character of the things.
Okay.
I think we can change it, like for the variable, if we go here, copy the variable. There is a thing variable view, you see here?
Variable view, we can do it.
So with the variable view, if I am just going this on, then this is, you see, string. Because when you give a number at the beginning, automatically it assumes as a string, okay? Like when I'm giving a letter at the beginning, then that name is regarded as a string. Oh, it's not taking C10. No, so C10.
Your variable length should be 3 because C is 1. And
no, I think we can define the name, I guess, variable view. So string width is, we have to send the width. So send the width to 3.
Which should be 3, yeah.
So then it will be all right. So come to data view here. And there's a C9, so she should be C10. C11, so C means catchment. C12, C13, C14, C15, C16, C19, C20, C21, C22, C23, C24, C25, C26, C27, C28, C29, C20, C30, C31. Okay. So we have 56 Casman, is that right? Ali Ahmad, can you see it?
Yes, yes, sir.
So now we can go to variable view and we can see that's fine. So now we can go to again to our analysis, which is our analyze or classify, hierarchical clustering, and we are selecting our variables from there. Up to forest, is that right? The variables, and then we want to get statistics, proximity matrix, and continue. We want the plots of dendrogram, and we also vertical is fine with us, and then continue, and method, you have to select the method. So in the method, I told that word method is widely used in hydrology, so we'll be using the word method here, and it's called Euclidean distance, fine with us, and standardize the variable. So what kind of standardization we want to do? Sanjim? Sanjim, can you hear me?
Yeah, yes, sir, I can hear you.
Z-score, sir?
What kind of standardization we want to do here?
Z-score?
So I'm not sure.
So what is the characteristic of Z-score?
So the variable will be normally distributed. The standardized variable will be normally.
What would be the mean of that Z-scores?
Mean is.
So mean will be one, sir.
Mean will be 0
Oh,
and,
zero.
and variance will be 1.
Unit variance.
So that is the standard normal distribution. Z has a mean of 0 and standard deviation of 1. Is that right?
Yep.
Yes.
So I told many times Z-score. How to do the Z-score? Tell me how to do the Z-score. I showed an example in one day in the class, and still I think I discussed it today as well.
So should we explain, sir?
Can you explain Z-score? How you do it?
Yeah. If we subtract the mean value from the observed value and divided by the standard deviation of that variable. So in that case, we'll get the.
So Z-score is x minus x bar divided by sigma.
Yes.
So each of the data value you divide score, you subtract it from the mean of the data series divided by standard deviation of the data series. Then it will give you, make you a Z-scores that will have a 0 mean and unit variance. This is very, very important transformation of the data. Okay, so we will take the Z-score and continue. And then we can ask the save the membership. So we have to give how many clusters we want. So first time we don't want to know how many clusters is there. So first time we want to do it just to see how it looks. The first thing in cluster analysis, look at the dendrogram. So you see the dendrogram here. So how many groups we can make for this data? Any student, Mutasem, are you here? Is Mutasem here? Is Amir here, Amir? Is Orpita here, Orpita?
Yes, sir.
How many groups we can consider for this data? For example, you are doing rainfall analysis and you are selecting, say, 80 rainfall stations from Australia, and you want to divide them into homogeneous groups.
So I think there might be 4 groups and
4 groups.
4
4,
groups
5.
and though instead of 4, there might be some heterogeneous group as well.
So when you do the group, then you have to draw a line, vertical line here, and it depends on where you're drawing the vertical line. If you're drawing the vertical line at 25, it's only one group of the data. If you're drawing your vertical line at 20, then it's giving 2 groups. If you are drawing a vertical line through 10, you are getting 3 groups. And if you're doing at a level of 5, then you are getting more groups there. So where you should draw the line? Ali Ahmad, where should we draw the line?
So in this context, I have no any idea how we cut off this value.
We have to cut where the differences is maximum, where the vertical difference is the maximum. So you see, if I am doing a cutting at 20, then I am cutting this length. And if I am cutting at 10, then I am cutting this length. So which one is the maximum between these two? These are very similar, is that right?
Similar.
So in my opinion, that we should cut at 20 and make into 2 groups first. If we are interested about 2 groups, it depends sometimes that really how many groups you want, because if you want 2 small groups, then you cannot develop any meaningful regression equation because you need at least 20 data points or catchments if you want to develop any meaningful prediction equation by regression analysis. So that's why I don't want to cut it here at 5 or 4 or 3. That will give me too many groups and some of the groups will be very small. Like you see one group here, only a few catchments here. Okay, so if I cut it here, then I will have 2 groups. And if I cut it here, then I will have 3 groups. So we can see here that in one group, catchment 54, 55, 26, 27, 7, 35, 12, 28, and 36, 13, 23, 37. These are coming into one group. So we may assume that these are kind of homogeneous groups. Of course, we have to test the homogeneity there are some statistics to test the homogeneity of the groups. For example, Hosking and Wallis-Hayes statistics. can be used to assess the degree of homogeneity of this group. And in another group, with big group, so really all the remaining Casemates, they are forming another group. And if I cut it at 10, then I'll have 3 groups. But this group is very small. It has only 1, 2, 3, 4, 5 Casemates. So Ali Ahmad,
Sir.
This is very, very important for you.
Yes.
You can see you have to ask the question yourself that why only this one, like Casement number 3, 1, 2, 6, and 5, they are forming a separate group. Why is that? And why they are very different to another Casemates which are far away? Like the distance, like the Casemates here, if they are closer in this axis, they are similar to each other. And if they are far away, they are more different from each other. So I would say that in this case, Casement 54 and 55 is very different to Casemates 20, 33, 11, and 38.
Yes, yes, it makes sense.
Then you have to ask the question why that is the case. And then you have to examine each of the Casemates in detail. That is the stream density very high for those Casemates? Is the slope is very small for those Casemates, or why? Why they are coming together like this? Why they are forming in a group, and does it make any sense? And again, at the same time, if I do another type of clustering analysis, whether they are coming to the same groups or not. So can you note it down, Ali Ahmad, that
yes.
Here your Casement 20, 33, 11, and 38 coming to a group. Write it down.
Yeah.
20, 33, 11, and 38. That is one extreme group. Another group is Casement 54 and 55.
Yes.
These are 2 extreme groups. And we want to see why they're extreme. And if I want to do another type of cluster analysis, whether they are coming into same group or not, let us do that. So let us analyze and classify hierarchical cluster analysis. And now when I go to the method, I want to use another method, say between group linkage. And I want to say continue. And I want to say okay. So now this is my dendrogram here. So what are your Casemates in a group, Ali Ahmad?
Sorry, sir.
Did you noted down the Casement ID?
Yeah, 20, 33, 11, and 38. And other one is 54, 55, 26, something.
What do you mean by something? I asked you to write the number exactly.
So I read only the 3 Casement number.
Okay, do it again. So this is one group here, 54 and 55 in one group, is that right?
Yeah, 54 and 55.
Write it down.
Yes.
And then another group here, write it down. How many Casemates here in the last group?
20, 33, 11, 38. Yes.
Okay, so start from 11, 20, 33, 38. So
yes.
They are forming in one group by one method of cluster analysis with the same data set. And now I am coming to the another method of cluster analysis. And in this group, I am getting 54 and 55. So in your previous group, there was a group with 54 and 55, is that right?
Yes.
So that means that 54 and 55 has something that is special for those Casemates. And what was another group for you?
That is 20, 11, 20, 33, 38. 11, 20.
11, 20, they are coming into one group, and
33, 33, and 38.
33 and 38 is not coming into that group, but they are
Three of 20, 33, 31, 11. Three of them are coming one.
So you have to do a correspondence analysis. This is a kind of another technique that you have to see the correspondence analysis between 2 diagrams. Okay.
Yes.
Okay, so now we can do some little bit more since we know that really the data seems to be, there are two groups there at least. So what we can do now, we can do again more analyze, and we can classify, and we can tell that we can say k-means cluster analysis. So with the k-means, we will be using the variables again. So these are the variables here. And we want to label the cases by variable that we created, the variable one. Label the cases by, we could have used that before as well, but they are coming. And we want to form two clusters because we found that there are two defined groups. And we want to say two groups there. And then we want to save the group membership, cluster membership, and distance from cluster centered as well. Continue. And we want to say, okay. So now in this cluster analysis, what it has done is, it has formed two groups. On first cluster, it has 21 members. Second cluster, it has 35 members. And if we view our data window, so in this case, we can see that our first catchment is in group 1, and catchment 7 is group 2. So group 1 has not that many catchments, you see, and group 2 is bigger. And this is the distance from the center of the cluster. So bigger the distance, the catchment is farther away from the center of that cluster. So does it make sense? Tanjim?
Yes, sir, it does make sense. Yeah.
So it means there are two groups in your data. So for example, how many catchments you are using in your thesis?
So 100.
100. So if you apply your cluster analysis with your data, then you may end up with two groups, for example. And then for each of the group, you can develop your regression equation, and then you can see whether your estimation error is reducing or not, for example. Whether your relative error is reducing by forming data into two different groups, for example.
I'm sorry, I have one question. In the other diagram, the one when you had all the clusters, there were some catchments where they didn't have, like at the end. Could you go back to that figure? Okay. So you can see like the if you go up, catchment just the catchment 13, 23, 37. Is there anything like special about them, because they are not you see from the line after 5, they're not forming anything. Like they're not part of.
They are forming group. Like what it's doing is like I say, it's the way it does it that catchment 54 and 55, they are closest to each other than any other catchment.
Yep.
Like it's something that when people marry, then they marry with one girl and one boy. So they are the most similar, for example.
Yep.
So 54 and 55, they are getting married. And then there are other people, they are forming groups together, for example. Like all of these catchment here, 26 up to 52 here, they are forming here their own group. But at the same time, it tells that this 26 is closest to this 54 and 55.
Yeah, makes sense.
So this diagram has a lot of meaning. Ali Ahmad has to understand it very, very well.
Yes, sir.
because this is your thesis and this is, you will be doing this grouping, your whole thesis on this grouping issue. And you have to understand it 100% more than me if you want to get your PhD.
Yes, right. I'll try, of course, sir.
So I think Tanzim asked an interesting question. So that really helps, that really, you see, like then as you going up, at the end, it's one group, everything. Like the way that you have considered all your 100 catchments into one group. So you are considering that one group. But if you want to divide that into smaller sub-regions, for example, your Queensland is very big, and it may be that catchments in the upper part of Queensland is different than the catchments in the lower part of Queensland. Because Queensland length is around 4,000 kilometers. At least 3,000 kilometers from Gold Coast to your up to the northern tip. It's a huge distance. What is the distance between Dhaka to Delhi?
Probably around 2,000. No, actually, it's going to be 5,000, I guess, because it's center of India.
No, find it out. Go to Google and find it out. Ali Ahmad, what's the distance between Dhaka to Delhi?
It's actually only around like 1,900.
Around 2,000, is that right?
Yes, 2,000.
A solver add-in.
So did you find it from Excel? From Google?
Sorry, if you have it already,
Yes.
just hit X and close out.
So you see the Queensland, the distance of Queensland from along the coast is around 4,000 kilometers. So it is really from Dhaka to maybe Kabul, or even more than that maybe. Can you find the distance from Dhaka to Kabul?
And then the output range is where you want your statistics to be posted.
So even that is like only 2,400 around
You
that.
find the distance from Dhaka to Baghdad.
Make sure you have summary statistics and confidence level for the mean checked. And everything looks good.
Yeah, that's like 4,500.
So you see Dhaka to Baghdad. So even the Queensland, distance of Queensland is that much.
Yeah, that's 6 countries, different countries. Yeah.
So that's why if you consider all of these catchments in one group, that is a stupid decision.
Recall
Do you agree with my point?
is
Yes,
the
sir.
area
Yep.
between
Totally.
the mean minus the confidence level and the mean plus the confidence level.
So you can see that somebody's talking. Can you stop your mute yourself and talk? Okay, so any more question on the cluster analysis? Who else are attending to the class today? Nobody's talking. Let me see who are in the class today. Okay, if you don't have any questions, I'll stop share. Saika, can you, or Gokhan is there, is that right, Gokhan?
Yes, sir.
So have you taken the attendance?
Yep, it's done. I did it.
That's good, that's good. So I can see Orpita is here, Ali Ahmed.
That's good. I can see from the page.
I can see I'm interested about, I want to know who the postgraduate student attending. So only 2 postgraduate students attending, is that right?
Only, yeah, Ali Ahmed,
Orpita and
Laura.
okay.
Yeah, and Saika here.
Yeah, Laura.
Saika is
Laura, yes, sir.
Oh,
Yeah,
Laura is attending as well, okay. So Laura, do you have any question?
No, all good.
All good, okay.
So I had a question regarding, can I ask, sir?
Okay.
I'm sorry, for the catchments in Queensland, I've seen that usually the data I get or usually we get is from the, because I've drawn a map of the location, it's usually in the near the coast. So like even though it's data is from the entire state of Queensland, it's only from the eastern coast of Queensland.
Yeah,
so like
yeah,
is there lack of station?
Because there are not that many stations in the inland because it's really not very much habitated there.
Yeah.
and not that many activities going on, because Queensland is so big and so much land is in Queensland. You can fit the whole Indian subcontinent there.
Yeah.
But the problem is like only people live along the coast because that's the best land.
Yeah. And all the constructions are all there, so
because most of the people are living in that area. That's why they need the road, buildings, and all the kind of infrastructure, you know.
Yeah.
And the interior part is the mining. So they are remote, and there are some roads and some things, but it's all mining, and they don't have that many stations. Who is going to record the stream flow there?
Yeah, makes sense.
Okay, anyways, I think that's all for today. I think our time is, what's the time is our 3 to 4:30 class, is that right?
That's true.
Yeah.
Okay, so you have a bit of time, but we have finished quickly today.
Sorry, quick question.
Yeah.
How much is this relevant for the undergraduates? Would this be?
That's a very good question.
But no.
That's a very good question. Really, first thing is that to pass your exam, I can give you a question on this. So that is one thing. But in terms of practical application, this knowledge is very useful in a lot of analysis, not only for this subject. You may have to group your sample for many different reasons. For example, you have rainfall stations, you may have to group them. You may have cylinder strength of the concrete, you may have to group them into different classes. So there are a lot of applications of this here. And it's very easy to apply as well.
I think so. You may just ask questions. We won't actually have to use it as such. Just you might ask a question on the application. I'm talking about like a final exam here.
Okay, final exam. That's right. Final exam will be open book. So final exam, open book exam. So there might be questions on this, of course, because that exam will be covering all the lectures. And I'm sure there will be one question at least, or part of the question from this lecture.
So will we be using the SPSS software for final exam?
This sort of things can be done in R as well.
But it's okay if we use SPSS as well, because we can access the SPSS from the remote.
I think all of you should be able to use SPSS, is that right?
We have to, it's not free, so we have to use the what do you call, the university STEM SCAM lab by using the...
But I think all the students, you can use it, I guess.
Yeah, I manage SPSS personally from my colleagues, but not from the university.
You should talk with your the PhD student, any students, you can talk with the IT help desk, and then you can get access to SPSS, particularly for PhD students, HDR students. If you ask IT help desk, they will give you like Citrix access to access SPSS remotely. I am using that Citrix to access university computer from here, and I'm using SPSS remotely. Okay.
Okay. So trial version can be downloaded from the IBM SPSS.
Trial version is like you cannot do a lot of things with that probably, and another problem is that it really allows you only for a few weeks, I guess, 1 month or something. Is that right?
1 month, yes, sir. 1 month.
So that's a good idea. During exam time, you download it, and then I will give some question on this, and you use SPSS.
Yes, sir, but I was thinking, like, would you teach us how to do all this calculation or R, or?
I think I will. Yeah, I want to.
Yes, because that would be helpful as well.
Yeah, that's right. That's right. We should use it. We have a special lecture on software applications. On that day, I want to use R for regression analysis and also many other analysis on that day. Because
yes,
we have a special part for R.
That would be very helpful, sir.
Yeah, because R is free, and you can use like just typing a command, that's all. Okay, so if there is no more question, then probably we can finish it here.
All right, thank you, sir.
Yes.
Oh no, sorry, sir. Just thank you.
Okay, Gokhan.
Yes, sir.
Once we finish the class, can we have a meeting on the paper that you are writing?
Yep. You can create a breakout room because some of the students still staying, not leaving. So you can send me the breakout room. And then
okay,
just,
so
yeah, make sure all students left.
we can go into breakout room because I have another class at 4:30, I guess. I have another meeting. So if you can finish before that meeting, that would be great.
Yeah, to be done until 4:30.
Okay, so I'm going from this meeting and then we can log in again, or we can do a breakout room,
Yep.
right?
Yep.
So breakout room.
We can leave now, sir. Okay.
Okay, you all of the students, you can leave now. Yeah.
Okay. Thank you, sir. Assalamu alaikum, sir.
Assign manually. Create. So I am assigning Saika here. Saika here?
Yeah, Prof, I'm here.
Saika and Gokan. Okay.
Yeah. You can start recording if you want to. Sure.
Yeah. Okay, so that's fine. I think a room.
Yeah, you can stop recording if you want.
Okay, so is it okay now, breakout room?
Yeah, I didn't get any invitation.
You don't get any invitation?
Yeah, we can leave and we can log in again if you want. I'm gonna leave. You can